Okay. Can you able to view the window? Okay. So 0 na bank 0, 0 1 na bank 1, 1 0 na bank 2, 1 1 na bank 3. Okay. This is a T-mod register thing. How we have to know na? Here you see timer 0, we have one set, and timer 1, I think it is repeated. Okay. We have 4 modes of operation. 4 modes of operation, we all know that 0 0 for mode 0, 0 1 for mode 1, 1 0 for mode 2, and 1 1 for mode 3. So this is applicable for timer 0 and timer 1. C bar, C slash T bar. You always understand C stands for counter and T stands for timer. So counter always counts the number of occurrences. Okay, for example, to understand the counter, if some of them are visiting the site, they will count a number of people have visited 12,000, 13,000 and all. For example, if people are entering into the mall, it will count the number of people. But timer all time dependent. We are speaking about frequency, na? It related to time. So you always remember C slash T bar, na? C is 0 na timer operation, 1 na counter operation. And we have a gate, 0 na internal clock, 1 na external clock. That we have to remember. Okay, that is only they have given here also. Okay. Actually, I think this is a small mistake. C slash T bar. T bar na T bar. Actually, C slash T bar na 0 will be a counter operation and 1 will be the timer operation. How we have to know na? Because it is C slash T bar actually. So it is nothing but a image, so I can't edit. I will edit and upload it. Okay, because T bar na 0 bar is 1. That is the meaning of that. So timer is low activated signal, counter is high activated signal. Okay, then these are the 4 modes of timer. We will go into this particular picture you can understand. Mode 0, mode 1, mode 2, mode 3. Okay, how we can understand now? Mode 0. Okay, we have 2 timers are there. Timer 0 and timer 1. Timer 0 na, you all understand TH1 8 bits, TL1 5 bits. Okay, so it may do how many counting na? 13 bit timer will be there instead of 16 bit. But mode 1 here 8 bit, here 8 bit. So how many bit will come? 16 bit will come. Okay, and mode 2 na, you always understand we always use TL timer lower order bit only. So 8 bit only we can use. And mode 3 also we all been using the we all use the timer 0 interrupt. We will use only 8 bit only. Okay, so this is 13 bit, this is 16 bit we are using. So we are using TL alone 8 bit, TL TH both are 8 16 bit. If I am using both, I will use 16 bit. I am using only 8 bit only. Okay, and this is also that. Okay, this is a timer control register. Timer control register. I think we have IT0, IE0, IT1, IE1, timer TCON register, timer control register. So while we are going for the theory, we will come to this. And this is SCON. SCON na serial control register. Serial control, we don't have a separate registers in 8085. Serial na UART. What is UART? Universal Asynchronous Receiver by Transmitter. So fix the XCL by 12, variable timer, all this will be, again we will go with the serial control register. Okay, these are the interrupt priority register. Addressing mode. Okay, now I will stop sharing this and I will take the week 5 to week 8. Week 5 to week 8 PDF. Okay. Okay, once again. Today morning I have put up Actually, before the meeting, 6 peoples are there. Now it become 9 peoples are there. Now it become, what to say, 6 peoples are there. You kindly give your feedback, ma. Then only I can understand. Okay, now I will go through the week 5, week 2. Okay. Which of the following statement is true? Okay, 8051 has 2 on-chip crystal oscillator. No. How many crystal oscillator is there? How many on-chip crystal oscillator we have? Huh? How
One.
many? One only. Okay. And 8051 has only one 16-bit timer. So we have how many timers? We have 2 timers. Okay. So B also false. D8051 has 16-bit IO ports. No. We have 32-bit because 4 ports are there. For each port, we have 8 pins. So 4 into 8, 32 pins are there. So correct answer is C. Okay. What is the function of port 3.0? I think parallelly I will open that. Can you able to view this window? Okay. 3.0. You go to this and see in 3.0. It is used for what, ma? 3.0. It is used for what? Serial input port. So now once again you come back. Serial input port. Can you understand? Port 3.0 is used for what? Serial input port. That's why I asked you to study that. Question 3. Which of the following component is not present in the hardware structure of 8051? Hardware structure of 8051. I'm moving on to that particular thing. Hardware structure of 8051. Okay, this particular picture is hardware structure. In this hardware structure, we can see that D flip-flop is there, latch is there, and you all know that it's nothing but when you grounding and you are seeing that it is a tri-state buffer. What is tri-state buffer? Na? 1 na high state logic, 0 na low state logic. Tri-state buffer na, it is depends on the impedance. So you see to our question now, D latch is there. Tri-state buffer is there. Transistor also will be there. What is transistor here? When you see to that, I am having a, JFET or MOSFET kind. M1 is there, na? That is JFET. So this is my tri-state. One triangular is there, na? That is tri-state. D latch, which is not available. Multiplexer. What is multiplexer, ma? What is multiplexer? What is multiplexer? Students tell me.
Many input give us
Single output. That is not available here. Okay. What is the duration of one machine cycle of an 8051 microcontroller with a 12 megahertz crystal oscillator? I told 12 megahertz divided by what? To find out for one machine cycle only we will find out. So 12 megahertz divided by 12, it's equal to what? 1 megahertz. 1 divided by 1 megahertz, what is my frequency? 1 microsecond. Okay. I think this I have put up this calculation. I have put up this calculation over here. Where is that? This particular slide. Okay. So study first week 5 to week 8 PPT, then come for the solution. What is the reset value of 8051 microcontroller program counter register? Reset value also I listed here. You see what is the reset value of program counter? 0000. So here also, what is my value of reset value of program counter? PC means what? Program counter 0000. What is the value of on-chip internal RAM locations or bit addressable? Can anyone remember on-chip bit addressable? You see here I have shown you that this particular slide. Cannot able to see? On-chip bit addressable 202 2F. Bit addressable is what? 202 2F. So here you see my bit addressable is what? 202 2F. Okay. How many register banks are available in 8051 microprocessor? How many register bank, ma? How many registered banks? How many registered banks are there? How many registered banks are there?
4, ma'am.
4 registered banks. What are they? Bank 0, Bank 1,
Bank 2,
Bank 2, Bank 3. 4 Bank 0, Bank 1, Bank 2, Bank 3. 4 banks are there. Which of the following is the memory address of Pecan register? So you see, go and see that Pecan register. What is the memory address of Pecan register? Pecan register memory address is what? 87H. So my Pecan register memory address is what? 87H. What is the address of tmod register? Tmod. Again, I have to go for tmod and I have to go through the address. Tmod is 89H. Tmod is 89H. Okay. Which, can anyone tell me the answer? Which of the following registered bank is selected? RS1 equal to 1, RS not equal to 0. 0, 0 na bank 0. 0, 1 na bank 1. Appa 1, 0 na?
2.
Bank 2. Very good. Bank 2. When pop instruction is executed, I think push and pop we already seen. Push. Pop, you remember popcorn. Popcorn means it is pop out. So remember, it will come out of the stack pointer. Push na, it is go into the stack pointer. Push na, register to stack pointer. Pop na, stack pointer to register. It is common in 8085 and 8051. So always remember, push na, it will always increment and it will upload. Pop na, it will decrement and upload. Okay, so that is common. So push and pop, this is the thing. So here push pop na, stack pointer always decremented by 1 in this. Which of the following is true context in the in 8051 microcontroller? So you see, IO port 0 is 8-bit general purpose input output operation. Port 1 is used as a address and port 2 is used for internal timer and external interrupt. And port D, none of the above. Actually, how many ports are there? How many ports are there, ma?
4.
How many ports? Port 0, port 1, port 2, port 3. Okay. Actually, port 1, we never use for any other thing. I think on this I have shown you. Port 1, this port 1, we were not been using for anyone. Port 0, address and data. Port 2 for address. And port 3 for timers and in serial communication. But when you see here, port 1, they said address and address. Actually, port we are not using. Which port we are using? Which port we are using for address bus? Port 2. So B is wrong. Here, when you refer this, port 3 is only used for internal timer and external interrupt. So that is also false. So port 0 is used for general purpose and input output. All the ports are used as a general purpose and IO operation. That is good. But port 1 will not be also used for general purpose and IO. It is never used for address bus. Port 2 only used for address bus. And port 3 only used for internal timer and external interrupts. Which of the following is true in the context of PSW16? See, PSW16. PSW16, now I have to write 16. How will you write 16, ma? PSW16, na, you see, this is my PSW. Where is my PS? Okay, PSW16, now will you write my PS? $16 now, what is the value? Tell me, ma. 0, 0, 0, 1, 1, 0, 0, 16, 1, 6. So tell me 0, 0, 0. I think I will share the whiteboard. I think. I'll go this. 16 now. Will you write 16 now? We all know 0, 0, 0, 1. 6 now. Will you write 0, 1, 1, 0. So this particular oneness decides the bank. Okay. So you see here RS1 and RS not. RS1 and RS not. So we all know that this is 1 and this is 0. This is 1 and this is 0. Now which bank will be selected? 1, 0 now. Which bank will be selected? Which bank will be selected, ma? Bank 2. So automatically bank 2 will be selected. Okay. Now you see what is the size of internal ROM memory of 8051? What is the size of internal ROM? What is ROM memory internal size? What is ROM memory internal size? 4K bits or 4 kilobytes? 4 kilobytes. Memory nale nam eppadi solluvom? We mentioned what? 4 kilobytes. 4 kilobytes. Okay. What is RAM capacity? Hey, first slide adana na sonna. 4 kilobytes ROM, 128 bytes RAM. Idana first point I told. 4 kilobytes ROM, 128 bytes RAM. Okay. Which of the following is true contest in the of 8051 microcontroller? Which is the bundle? I think both are same question. I think 13 and A. Again, I am saying input output 0 is used as a 8-bit. So this is my 5th week. Okay. So I think you may understand you are my 5th week. Next we will go for 6th week. Have you understand 5th week, ma? Have you understand?
Yes, ma'am.
Okay. Now, I think quite we will see one by one according to the question. Which of the following instruction 8051 is not permitted? So see here, I think I have put up all the instruction sets of 8051. See, in 8051, these are all my data transfer instruction. This is my arithmetic instruction. And this is my logical instruction. And this is my branching instruction. Okay. So, and apart from that, we have machine control instruction. So, you always remember, at always denotes the we were been saying it is moved to the particular address of the, I'm moving my data to the particular at array. At array denotes what? Address. Okay. And move X na external memory, external RAM that we have to mention. Push pop, we all know that. XCH na exchange. Okay. Addition, we don't have multiplication and division in 8085. That is one thing. So if I multiply 2 8-bit, my answer will be having 16 byte. So lower order will be stored in B register. Higher order byte will be stored in the accumulator. Okay, if I divide 2 value, my quotient will be stored in A register. My remainder will be stored in B register. Okay, and these are my Boolean variable function. Okay, clear C, set to the particular bit, complement the bit, ANL na AND operation. Here also we are having these 3 things. AND OR, exclusive OR. Okay, exclusive OR will be there. And here also call. Call means what? Call means my instruction will jump from main to subroutine. Return na subroutine to main. That is the thing. Okay. Now, if I here, I want to, what is, we will see one by one according to the program. Okay. Which of the following of 8051 is not permitted? Okay. Add A, 4. I can add my A. But you all remember that I can move my accumulator to R0. Moving from one bank register to another bank register, not possible. It is only with the help of CPU, bit addressable register only. We all know my DPL is also a bit addressable register. So the third one is false. Moving from one bank register to another bank register will not be permitted. That you remember. Okay. Then which of the following instruction is equivalent to move a comma hash 55? A comma hash 55 na, you always remember what is the meaning of that na? My accumulator value is my accumulator value is 55. Are you clear? Hash always denotes, there we used move immediately now. Here we all know my accumulator is how many bit data ma? 8 bit. Okay, so it can store only 8 bit at a time. So 55 now how I can write 0 1 0 1 0 1 0 1. So totally how many bit? 85. What is this move? This all now how I can tell you now. Sorry. How I can do now? See here I told one of the very important one, and we have seen now this question. Tell me what is the accumulator address for this? What is my accumulator address? Refer the diagram, tell it. What is my accumulator address? E0. My accumulator address is E0. Okay. So my accumulator address is E0 now. You have to remember, instead of this, what I can put? Move, instead of A, what I am putting? 0 E0 H. Why I have to always prefix 0 now? Sometime microprocessor or controller will take that E as a alphabets. So differentiate that only. We always putting prefix 0. So even it is F, we will add up put it 0. There is B and C also, both are same. But in C, hash is missing. That is the thing. So what is the equivalent na? Move 0. What is the address of my accumulator? 0 E0 H. Okay. Then my third question. What is the function of mul AB? Mul AB means we all know multiply the A register and B register. My B register will always store the lower order byte and my A register will always store the higher order byte. So you see, higher order byte of the result will be stored in B register. That is wrong. My B register will always store the lower order register and my A register will always store the higher order register. So I told na overflow flag, OF, OV, we have seen in the PSW. So whenever during this multiply instruction only, this overflow flag will be set to 1. Okay. Move tmod hash 20h. Move tmod hash 20h. Okay, I will move on to this. Students, are you listening? Students, are you listening?
Yes, ma'am.
Yes. Okay. Okay. Tmod 20h. Tmod register. Okay. We will see here. Tmod 20h. Tmod 20h na, you have to substitute my 20 value here. 20h na 0 0 1 0 0 0 0 0. So you always remember 0 0 1 0 0 0 1 0 na, this 1 0 I'm selecting what ma? I'm selecting what register? Timer 1. Okay, I'm selecting timer 1. 1 0 denotes what? Timer 1 mode 2 register is selected. Timer 1 mode 2 operation is selected. Can you understand? I have to substitute the value. In that I have to check. That's why while you are studying, you have to know the format of tmod register. Okay. So while I'm going for my PPT, I have to clear the annotated. So you see, timer 1, mode 2 of timer 1 is selected. So that is my true, my option. Okay.
Ma'am, 10 is
What ma?
10 is 0
Mode
is
to
3.
20H ma. Mode to 20H na, you see, I have to put for 20, 0, 0, 1, 0. Can you able to see here? 0, 0, 0, 0, 1, 0. The remaining here all are 0. 1, 0 na, it is in what mode? Mode 2. Which timer will be there? Timer 1. So timer 1, mode 2 is selected. Okay.
Okay.
Then which of the following statement is true if the timer operates in mode 2? Okay. You all understand while we are been studying with all the modes. These are the modes. Mode 0, 13-bit. Mode 1 na, it will store 16-bit. Mode 2 na, it always here also we have a reload option will be there. And mode 3 also we are been using TH0. This is also 8-bit timer. Okay, so while I'm looking on to that, mode 2 operation. So mode 2 operation, TL register overflows and TL is reloaded automatically with the original value by the TH register. Okay, we have seen that. Mode 16-bit timer is which mode ma? Can you tell me 13-bit mode, which 13-bit timer will work for which mode? 13-bit timer work for which mode? Mode 0. 16-bit timer will work for what? Mode 1. Then you all seen that auto reload mode will work for what? Mode 2. And mode 3 also a 8-bit timer, but it runs depending upon the interrupt condition. Okay, so you all understand? If you got the word reload, always represents what? Timer 1 mode 2, it's a 8-bit auto reload. Why we are saying 8-bit auto reload? Now, refer the picture. In this particular picture, you can see that in this particular picture, we are having TL, then automatically it will reload and then it will start. So it's a 13-bit, it's a 16-bit, and this is a 8-bit auto reload. Okay. Which of the following is not a valid 8051 instruction? Valid 8051 instruction. I have given 8051 instruction, all 8051. You kindly look on to that 8051 instruction. We have increment. Again, we have only 10 minutes. Okay. INCA, INC-DPTR, INCA, INC-DPTR, DECA. But we don't have decrement DPTR because it is external code memory only. We will access this data pointer. So the wrong one is what? DEC, DPTR. Decrement data pointer is not available. Addressing mode you see here. Immediate addressing mode now, remember this hash symbol will come. Okay, register indirect addressing mode now, at symbol alone will come. Okay, indexed addressing mode now, at plus this plus symbol will come. Implied addressing mode now, no operand will be there. Okay, no operand insert, the instruction it will specify what to do. Okay, register addressing mode now, I told that between two bank register is not possible. I can move my data to bank register to accumulator or accumulator to bank register is possible. Direct addressing mode now, directly I will specify the address. So remember hash, I will repeat once again, hash for immediate addressing mode, at for indirect addressing mode, at plus symbol for indexed addressing mode, and direct addressing mode I will directly specify. Okay, now we will go. Students, shall I stop the 6th week itself? Can you tell me? Because again the meeting is end over by 8 minutes. Huh? Shall we have it on Wednesday? Yes or no? You may study this 2 weeks and come. Is clear?
Yes.
Okay. So you tell me move R3, 0, F8. Address is directly specified. So it comes under what ma? Direct addressing mode. Now, which of the following is not a special function bit addressable? So listen, PSW we have address. TCON we have address. SCON we have address. Only TMOD. TMOD means timer mode control register. So when you go with this particular thing, it's not a bit addressable. So you see that. No, it's all. It's not a bit addressable now. All these are bit addressable. This TMOD alone, not a bit addressable. Okay, I think these are the SFR. Bit addressable now. You see this particular slideshow. These are the bit addressable one. So see TH1, TL0, TL0, TMOD, not bit addressable. So even though see, it's not a bit addressable register. So I have given what, thus learn this PPT alone. Then you may understand well to answer the question. Okay. Okay. CACOV. After following instruction are executed. A is 3F. Okay. Now I will put A is 3F. 3F means what is the value ma? 0, 0, 1, 1. F na 1, 1, 1, 1. 2, 3 na, 2, 3 na, what is the value? 0, 0, 1, 0. 3 na, what is the value? 0, 0, 1, 1. Now you add 1 plus 1, what is the value? 0. My carry will be 1. 1 plus 1, 1, 0. 1, 0 plus 1, 1. So again my carry will be 1. 1 plus 1, 0. Again my carry will be 1. 1 plus 1, again my carry will become 1. 1 plus 1, again I am having 1. 1 plus 1, 1, 0. 1, 0 plus 1, 1. Okay, again my carry will be 1, 1, 0. So we can understand that I don't have extra 1 bit. So my carry flag is 0. That's correct. Okay, auxiliary carry. Auxiliary carry na, if my carry is generated on the third bit, D0, D1, D2, D3. Okay, we all know that auxiliary carry, that is also be there. Okay, so carry flag is also 0, overflow flag is also 0. So my auxiliary carry flag alone 1. So the A only, it will be that. Okay. Then 10th question. Which of the following statement is true for div AB? Division of AB. So we all know that my A will store the quotient and B will store the remainder. So I think they shuffled the option. So div AB na, this is the thing. Division or the quotient will be stored in A register and remainder will stored in the B register. 11th question. What is the content of the accumulator after the execution of the following program? So move A comma B. I think I will take the annotator. A na 0, 0, 0, 1. 2 na 0, 0, 1, 0. 18 na 0, 0, 0, 1. 8 na 1, 0, 0, 0. So we all know that 0, 1, 0, 1, 1, 0, 0, 0. So we all know that I'm getting 0, 0, 0, 1, 1, 0, 1, 0. I have to check which number, which 4 bit is greater than 6. I think my lower order bit only greater than 6. If greater than 6, now I have to add 6 to that bit. 6 now we all know I have to add plus 6. So 0, 0, 1, 0. So now tell me the value. 0, 1 plus 1, 0, 1, and 1, 1, 0, 0, 0. Actually, it is 2A. Okay. 1, 0, 1, 0. Again, I have to add 6. If I add 6, again, what I will get? 30. Okay, correct. 30, I will get it. Here I am getting, again I have to add 0, 1, 0, 1. So if I add, again what I will get, 1, 0, 1 plus 1, 0, 1, 0. And then I will get what? 1, 1, 0, 0. So I get, sorry, this is also 0. I will get 30. Okay. So I have to check which is greater. Or else I can convert my 2a to binary. Okay, sorry, decimal. Then which of the following is not a legal in 8051? Okay, which of the order I can do all the rotation with the help of my registers only, 80, accumulator only. So RLB, that is not possible. Okay, that is the D is wrong. Swap in a very simple, 72 will become 27. My lower order byte will be stored in 72 na 27, 87 na 78, like that. Okay, 72 will become 27. Which is, what is the function of tmod register? So we have seen that tmod register is to set various modes of timer bar control. We can see that I can use timer 0 or timer 1, whether I have to operate in mode 0 or mode 1, mode 2, mode 3. All this will be set by timer mode, tmod register. Okay, so that is the one thing. Tmod is used to load the count of the timer. That is not set by the tmod. Tmod is used to set the mode of operation only. It is the destination or final register. No, it won't store any results. It will be stored in timer register only. It is used to interrupt the timer. No, I have a separate timer flag to interrupt. Auto reload mode. Auto reload means what? Reload word it is used to what mode? Mode 2. Is clear? So I think we all been seen 2 assignments only. So please kindly study because